Okay, let's continue with an example. Evaluate the line integral of 2 plus x square y on the curve C. Here C is the upper half of the circle. X square plus y square is equal to 1. So in order to solve this kind of problems, it's good idea to have the parametric representation of the curve. Since we have a circle here, the parametric representation of the circle is x equals cosine t, since the radius is 1, y equals sine t, and t is in between. Since it is the upper half of the unit circle, t is in between 0 and p. Okay, so the line integral of 2 plus x square y ds is equal to integral from a to b. Try to remember the formula of the line integral on the curves. Integral from a to b, in this case from 0 to pi. We write the function. Okay, instead of ds we have x prime square. X is cosine t, x prime is minus sine t. Minus sine t square is sine square t. Sine square t plus y prime from the formula. Y prime square. Y is sine t. Y is sine t. Y is sine t. Derivative of y is cosine t. Cosine t square. Cosine t square. Okay. dt. It is equal to integral from 0 to pi. 2 instead of x and y here, we should write cosine square t times, instead of y we have sine t, close the parentheses. Then we know that sine square plus cosine square is 1. Then you have dt. Okay, the rest is just to compute this integral. You have integral from 0 to pi 2 plus cosine square t sine t. So how do we compute this integral? If you compute, you will find 2 t cosine cube t over 3 integral from 0 to pi, and this is equal to 2 pi plus 2 over 3. You can easily compute, you can easily use the techniques from calculus 1 to compute this definite integral.